Welcome to the world of chemistry. Chapter 6 Thermodynamics. This is the e-content lesson 11. Let us learn and enjoy chemistry in a simple way. Today we will learn about third thermodynamic function, entropy. It is denoted by the letter capital S. Second law of thermodynamics, entropy and spontaneity, criteria for spontaneity. What is randomness or disorder in the case of solid and liquid and gas? Is it decrease or increase from solid to gas? Disorder increases. Gas has higher disorder. Which has highest entropy in the case of solid, liquid and gas? Of course, we have learned gas have highest entropy because of more disorder or randomness in gas. Again, because gas can exist in a large number of different microstates and their disordered movement. Can you define the entropy? Letter S. Entropy is defined as the measure of disorder or randomness in a system. See the diagram. When solid changes into liquid, what happened to entropy? Entropy increases. That is, randomness or disorder increases from solid to liquid state. That is, delta S value greater than 0 or delta S is equal to positive. Again, see the diagram. Liquid changes into solid. What happened to entropy? Entropy decreases. That is, delta S less than 0. That is, delta S is equal to negative. Likewise, liquid changes into gaseous state. What happened to entropy? That is, disorder increases or randomness increases. Delta S is equal to positive. Can you define entropy? Entropy is defined as the maximum randomness or disorder in a system. Which law introduced the concept of entropy? Second law of thermodynamics. Second law of thermodynamics introduced the concept of entropy. It explains the spontaneity or feasibility of a process. Can you heard about the term spontaneity or feasibility? That is whether the reaction take place or not. Can you define the second law of thermodynamics? The second law states that the entropy of the universe always increase in the course of every spontaneous process. See the video. Can you give the equation of second law of thermodynamics for a physical process? Delta S is equal to delta S final minus delta S initial. What about the entropy for a chemical process? Delta S is equal to S product minus S reactants. Can you give the equation for entropy for a reversible and isothermal process? Delta S is equal to Q reversible by T equal to delta H by T. That is, enthalpy change is equal to heat evolved or absorbed by a reaction. That is, delta H is equal to Qp. That is, in this equation we can say delta S is equal to Q reversible by T or delta H by T. What is the equation for entropy for a spontaneous process? In a non-isolated system, delta S total is equal to delta S system plus surrounding. That is, delta S total means delta S universe equal to delta S system plus surrounding. If delta S universe is greater than 0 or positive, it is a spontaneous process. Can you define spontaneous process? It is a natural process. It is a process that take place its own account or no initiation or needs some slight initiation. What is the criteria for spontaneity in chemical reactions? First criteria is the energy or enthalpy factor and spontaneity. Example, half N2 gas plus 3/2 H2 gas gives NS3 gas. Delta HF is equal to 46.1 kilojoule per mole. Students, from this equation, whether the reaction is spontaneous, what about the value of delta H? It is negative 46.1 kilojoule per mole. And what type of reaction it is? Exothermic reaction, that is evolution of heat, that is accompanied by enthalpy changes. Here the product ammonia has lesser energy compared to reactants. Can you give the first criteria for spontaneity? That is, it has the tendency to minimum energy and maximum stability is the first criteria for spontaneity. Next equation, half N2 gas plus O2 gas gives NO gas. Delta HF is equal to plus 33.2 kilojoule per mole. Identify this reaction. What type of reaction it is? Absorption of heat, that is endothermic reaction. Delta H value is positive for a endothermic reaction. It is spontaneous. So for a spontaneous process, delta H positive for a endothermic reaction. That is, exothermic reaction, delta H is negative for spontaneous process. For endothermic reaction, delta H is positive for endothermic reaction to be spontaneous. What about the second criteria for spontaneity? Randomness or disorder. Yeah, entropy factor and spontaneity. The tendency to have maximum disorder or randomness in a system, that is delta S is positive, is the criteria for spontaneity. Example, sulfur trioxide gas gives sulfur dioxide gas plus half O2 gas. Here delta S is positive, that is the product have more gases. Then another equation, H2O liquid changes into H2O solid. What about the entropy? Liquid changes into solid state, disorder decreases. That is delta S is negative. Hence it is a non-spontaneous process. But enthalpy factor and entropy factor cannot alone predict the spontaneity of a process. Can you predict spontaneity in isolated system? What is isolated system? In isolated system, there is no exchange of heat or energy between system and surrounding. Then how will you predict spontaneity in isolated system? The disorder or randomness increases, entropy increases. The delta S value will be positive for a spontaneous process. In isolated system, entropy considered only in the case of system only. Then when disorder increases or randomness increases, the value of delta S will be positive for a spontaneous process. Can you predict spontaneity in non-isolated system? What is non-isolated system? Here the heat is exchanged between system and surrounding. In non-isolated system, we have to take into account the entropy change of the system and surrounding. For a spontaneous process, delta S total or delta S universe is equal to delta S system plus delta S surrounding greater than 0. That is, delta S equal to positive for a spontaneous process. Students, what about the freezing point of water, whether it is spontaneous or not? H2O liquid convert into H2O solid. Delta S is equal to negative, indicating the process is non-spontaneous. But we observe that the freezing point of water is spontaneous at 272 Kelvin and 1 atmospheric pressure. That is, increase of entropy of the surrounding is more than decrease of entropy of the system, such that the total entropy change is positive, that is spontaneous at 272 Kelvin and 1 atmospheric pressure. From this study, some processes are spontaneous, that is freezing point of water is non-spontaneous normally, but it is spontaneous at 272 Kelvin and 1 atmospheric pressure. Such case, we have to consider the system and surrounding such that the total entropy change is positive. Such case is spontaneous. Then we can do an assignment. Students, give an equation for second law of thermodynamics for an isolated system. Delta S universe or delta S total is equal to delta S system plus surrounding greater than 0. That is, delta S is equal to positive for a spontaneous process. Students, you have clear idea about the term thermodynamics, the criteria for spontaneity and second law of thermodynamics. Thank you students. Learn well. Thank you.